Assalamualaikum warahmatullahi ta'ala wabarakatuh. How are you? Everybody okay? All right.
Alhamdulillah, okay.
Okay, good. We have the quiz today, but I will give you the quiz toward the end of the class, so that there will be time for submission, and then then we. So for the first half an hour, I will give you like 35 minutes for the quiz. So for the first half an hour, we will continue our discussion with the things that we left on Monday. So we were talking about what? We're talking about the first derivative test. First derivative test. So this is the continuation from where we left on Monday. So for the quiz, okay, I want you to turn on your video. Okay, for now, it's okay, because now we are having the class. So let's go back to where we were talking about this is essentially the first derivative test. So when you want to do the first derivative test, what you want to find is this. You want to find, or you want to determine whether the function has a relative maximum or a relative minimum by making use of the derivative. So if you look at the picture, did I ask you to look at the picture? If you look at the picture, this one, all right, if you look at this one, you will see here the function or the curve is going down and then going up. So the critical point here is a relative maximum point. I'm sorry, minimum. Okay, and I think I have another graph. Okay, over here, you will see the line or the curve goes up and then goes down. So that critical point is a maximum. So basically, we use first derivative. Okay, you sketch the graph, or you can relate the behavior of the function, increasing, decreasing. So you have a maximum. So we are talking about the maximum or minimum point at the critical point. Okay, so we're talking about the maximum or minimum at the critical point. And when you have a maximum, what do you have? You have the curve going up and then going down. In other words, the curve is increasing, or the function, okay, the function is increasing, reaching the critical point, and then decreasing. Right? In terms of the slope on the interval to the left will be what? Will be increasing. No, I'm sorry. The slope from the left, or the interval on the left, is positive. And then on the interval to the right is negative. So you can relate the y prime and the nature of the curve, whether it is or decreasing. And then we can say whether the critical point is maximum or minimum. So what I did last time. So what we were doing is, in order to determine whether the curve has a maximum or minimum, first you take the y prime. Right? So the steps are already written here. So I will add. Okay, I will add the purpose. You want to relate y to y prime. Of course, that is what we want to do. But we also want to do this. You want to determine whether the function has a relative maximum or minimum. So you have the relative maximum minimum at the critical point. So here the first derivative test. First derivative test. What you were doing here is you relate the y prime to y, okay? And then we can say about the function has a maximum or minimum. So you want to determine, okay? You want to determine if y equal to f of x has a relative. Sometimes you don't have to put the word relative maximum or minimum at the critical point or points if there are more than one point. So what are the method or what are the steps? First, you take the derivative, you take y prime, okay? You take y prime, and then you set y prime to 0. That will give you the critical point, okay? Call it x star, y star. Based on the critical point, you break into intervals, okay? So you break interval, as we know, it's based on what? Based on the critical point. The critical point will separate the values of x into intervals. So for each of the intervals, you relate the behavior of y prime to y by using what? Using a test point. Okay, we just use a test point to check the y prime and what is the value of y prime. Then we conclude whether the function is increasing or decreasing. Okay, so we just take a test. But that is what we already did. So if we continue from here, okay, we did this example. All right, you have the critical point is at 0, and then the value of y at the critical point is also 0. So you got 0, 0. So that is our critical point. Now that critical point will break the values of x into intervals. So you have two intervals, one to the left, that means x less than 0. X. Okay, Ilham, can you turn on your mic? Ilham, turn off your turn off your microphone, please. Okay, good. So you have the intervals, and then you take one test point for each interval. So we already did that. You have for the x less than 0, that means interval on the left, we take x equal to -1, then y prime is equal to -2, that means y prime is less than 0. So negative derivative means what? Means y increases. No, y decreases. So y will decrease over the interval. All right, so you need only one test point to generalize the behavior of the function over the interval. So here is over the interval. So over the interval, the function is decreasing. So you need only one test point to check. And then on the other interval on the right, x bigger than 0, we use x equal to 1, you got y prime equal to 2. Therefore, y prime is positive, bigger than 0. That means y increasing. So y increasing also over the interval. So we are able to, okay, now we're able to determine whether you have a maximum or minimum at the critical point. So first, we just sketch the graph. So I sketch this graph. So you have the critical point, and then you have the function decreasing from the left and then increasing to the right based on the interval. So we say that the point 0, 0 is a relative minimum. Okay, so here, what we want to say is this. Based on what we were doing, okay, based on what we were doing, we can conclude that the function, so our conclusion based on the steps that we have earlier. So number 5, I think it's number 5. So number 5, we can say that the function y equal to f of x has a relative maximum, okay, at the critical point, x star, y star, if what? Or I'm sorry, we started with a minimum, so it should be minimum. Okay, if it is a minimum, then what can you say about the function? So minimum means you have something like this. Okay, so you have something like this. So what can you say about the function? Based on the interval. Okay, based on the interval, for a minimum, what can you say about the behavior of the line? So what can you say? We just describe. Okay, you just describe. So if you have the function decreasing, okay, from the left, right? The function decreasing from the left. In other words, y prime is negative, okay? And then on the right interval, you have the function increasing, y prime positive. So therefore, critical point, what? The critical point, x star, y star, the function has a critical point at that the function has a maximum at that point. Okay, so we just describe what we have from the graph. You know? So the function has a minimum x star, y star if what? If, all right, if the function is decreasing, okay, on the interval, on the left interval, and what? And the function is increasing. Where? On the right interval. So left, right means the reference point is the critical point. Okay? The function is decreasing on the left interval. In other words, y prime negative. And the function is increasing on the right interval, y prime positive. Okay, so that is a minimum. And one way to confirm that, one way to confirm that is sketching the graph. Okay, sketch the graph. That will be easier. Okay, sketch the graph. All right. Okay. Number 6. The function y equal to f of x has a relative. You don't know it. Maximum at the critical point x star y star. If what? If the function is increasing on where? On the left interval. just the opposite. And the function is decreasing on the right interval. Okay. All right. So in terms of y prime, here y prime positive on the right interval, here y prime negative on the right interval. I'm sorry, y prime positive on the left interval, y prime negative on the right interval. So you have a maximum at that critical point. So I show you the other picture. Okay, this one. So here you have what? I have the function increasing from the left, reaching the critical point, and then decreasing to the right. In other words, the y prime is positive over the interval to the left, and then y prime negative over the interval to the right. So you have a maximum. And to confirm that, it's always good. You sketch. Okay, so basically that is what we call the first derivative test to determine the maximum or minimum point of a function. Okay, any question? So we have done this example. So based on this thing here, we conclude what? So our conclusion here is this: based on what we were doing, then y equal to x squared has a relative minimum at 0, 0. Pergi kat ibu, aku ada kelas. Saya untuk cek. Okay dah. Okay, bye. All right. So has a relative minimum at 0, 0. Okay. And for the other function, after you did this, we say that y equal to negative 10x squared plus 21 has a relative maximum at 0, 20, because that is the critical point. There. Right. So that is the first derivative test. Okay. Any question? Anything? Okay, I'll give you one question. I want you to do it now. Okay, I'll give you 10 minutes for our practice. We apply the steps that we were discussing, and then you get the intervals, and then we will be able to say whether the function has maximum or minimum. So I'll give you one question. You look at the book. Okay, go to the book. We give you one question. Okay. I want you to do question number 22. Okay, question number 22. You go to 10.1. Right, question number 20. The graph, okay, the picture of the curve is already been given. So we know already how the curve looks like. But I would like you to do all over again. Okay, do everything and then sketch the graph. So I want you to do the first derivative test. Okay, do it now. Now, if you have any question or any problem, you raise it up. Okay, so that I will go through. I go through the thing again. So you apply the steps that we have here. Apply step ni je. Okay. Okay, all right. I want you to try. So if you have a problem, okay, you raise up. I will go through because this is a very important part of the course. We will do this a lot, all right? Not actually the test, but this will become the basis of the test for maximum, minimum, you know, so that we have some idea on on that thing. Okay, all right. So do it now. Go ahead. The function is, you know, the function y equal to half squared, blah blah blah. Okay, so if you see the thing, that will be the Okay. You got the critical point? Anybody got the critical point? The first person who get the critical point, let me know. What is the critical point?
4 -7.
4, -7. Everybody, other people get that also? Okay. So first, all right, I go step by step, but I want you to do the step first. So first, you need to find critical point, because that will give you the intervals, okay? Or sometimes you have more than one. So what you do, you take the derivative, that will be equal to what? It will be equal to half. I write everything here, 2x minus what? Minus 4. All right. So for critical point, set y prime equal to 0 for critical point. That means what? That means x minus 4 is equal to 0. X equal 4. So you put into the function, you get y. All right, so you do that. So our critical point, call it x star y star, is equal to what? Is equal to 4 -7. Okay, all right. Now you have the intervals. So based on that critical point, you have the interval. So one way to check the interval, you don't have to do this, okay? Because we already know how to do it. But just to give intuition. So you got the number line, 0 here, 4 is here. So that critical point, this is the x, the number line x. So how many intervals do we have based on that critical point, critical value of x? How many intervals do you have here? Okay, cepatlah. The first person who get the interval, let me know. What intervals? Okay, cakaplah. What are the intervals?
-5, -3.
The interval. Based on the critical point, okay. Critical point is 4, -7. Okay, now what are the intervals? It's not -5, -3. Interval means like what we were doing tadi. Okay, somebody else. What are the intervals? Okay, no, Parahin. Interval. What are the intervals? Cepatlah. Okay, cakap. Hentam lah. Lagi dengan hentam. Tadi Haris gap 5, -3. But that is not the one. So what are the intervals? Or just tell me one interval based on that critical point. Okay, hurry up.
Sir, do you mean like interval 0 to 4?
Interval macam tu lah. Okay. Interval macam kita bincang tadi lah. The one that I show you for the example. So one interval, give me one interval. What is it? 1, 0 to 4.
1.5.
No, I don't want you to give the point. I want you to give. No, I think you misunderstood. It's not the point. Okay, it's not one point. Give the interval, the whole interval. Interval, you know interval? The whole region. You know, you don't give me 1 point. You give me the interval based on that critical point. What you give me is just 1 point. You know, we don't want 1 point. 1 point, of course, we want, but afterwards. But now I want the interval, the whole region, okay? The whole set of points based on the critical point. Okay. Well, what is one interval? Give me one interval.
Interval 2, sir.
Interval 2? What do you mean interval 2?
I'm not sure, sir.
Interval is like this. You know, if you go back to what I was doing here, you know, that example, based on the critical point, you have interval. One interval is from zero to infinity. You know, here, the other point is 0 to negative infinity based on that critical. So that is the interval that we want for that question, for that example. So if we have the critical point 0, 4, I mean point 4, -7, okay. So what are the intervals that we have? Okay, somebody back. Okay, one Samir. What are the intervals? Can give me one interval. What were given was only 1 point. Okay, we don't want 1 point. We want the interval. Okay, one Samir. Try.
For to infinity, sir.
4 to infinity. Okay, that's one interval. 4 to infinity. Okay, good. So 4 to infinity is what? Is the interval to the right of 4. Because what is the separating point to the interval? The critical point. Okay, so you have 1 to infinity. So that is one interval for infinity. Okay, what are the other interval? Or what is the other interval? You know. Okay, what is the other interval? Sami, nak sambung pun boleh. Okay, continue je habiskan. What is the other interval? Because when you got one interval, you should get the other interval. What is the other interval?
Negative infinity to 4.
Negative infinity to 4. Okay, negative infinity to 4. So that is the other interval. So there are 2 intervals. Now you don't worry about that 0. Okay, that 0 is the origin. The interval is not based on the 0. Okay, the interval is based on what? On the critical point. Okay, X star here. The one that we did, the critical point was 0. So 0. Okay, but you don't worry about the 0. The 0 is only the origin. Okay, the one that you break into interval will be based on what? Based on the critical point. If the critical point is, you know, I can give you another example. If the critical point is, say, 10. Okay, you have another case. Say critical point, star equal to 10, 24. So you don't worry about that 0. Okay, critical point here is 10. So what are the intervals? Cepat.
10 to infinity.
10 to infinity. The other one is
Negative infinity to 10.
negative infinity to 10. Okay. All right. I give you I give you one more. Suppose the critical point is here, negative 20. All right. So don't worry about all these things. Okay. Or even you don't have to put the 0. You know. So what are the intervals? The interval will be from negative 20 to infinity. Negative infinity to 20. Okay, so that is the importance of the critical point. All right, okay, that's number 1. Number 2, let's say we have 2 critical points. I suppose, because there are some functions where if you have a cubic function, you have 2 critical points. Suppose we have two critical points. Say one is -5, the other here is 12. So how many intervals are there?
3.
3 intervals. Okay. One is to the right of 12. So you got 12 to infinity. The other is in between. Okay, -5 to 12. And the last one will be, you can go either way or here, -infinity to -5. Okay, so don't worry about how many intervals will there be. That will be determined by the critical points. If you have one critical point, there'll be, of course, 2 intervals. All right, but if you have 2 critical points, then you see here there are 3 intervals. Okay, you don't have to remember it. Just do the interval based on what? Based on the critical point. Okay. All right. So you have 2 intervals. So now, okay, now that is what when you do the what? You do the tabulation, and then you take one test point. Masih ni lah guna test point. Okay. All right. You continue. You tabulate the interval, which we already set here. You take test point for each interval and see what is the value of the y prime. Okay, do it now. I give you 4 more minutes. Okay, I draw the intervals. So you do the tabulation. Okay, you have the intervals here, and then you see what is the y prime and how it relates to y. So first interval is -infinity to 4. Second interval 4 to infinity. Okay, now, what test point did you take for the, say, first interval? From negative infinity to 4, what is a good test point? 0. Okay, we take 0 because 0 is the simplest number. And then for 4 to infinity, kadang dia lah. You can what 5 lah. 5 is the lowest, or you can use 10. Okay, so for the first interval, you can take 0 easy. So let test point x equal to 0. So what is our y prime? Y prime, you substitute the value 0 into that thing. So what do we get? You get 0 minus 4. That is equal to negative 4. Now negative 4, what is it? Negative or positive? Negative. So what about y? Negative, y increase or decreasing?
Decreasing.
Y
Decreasing.
So that for the first interval. Now second interval, you take test point equal to apa? What test point did you do? Katakan 6. Okay, you can use whatever you want. And then y prime is 6 minus 4. That is equal to 2. 2 is positive. Okay, so you must say positive or negative lah. And then what happened to y? Y will be increasing. So you can see there, to the left of the interval, I'm sorry, to the left of the critical point, I mean from the left, the function is going down. All right, going down, reaching the critical point 4, and the value of y is negative 7 back. 7 lah. And then what happened to the y? Y increasing. So what you have for the critical point? You have what? You have a minimum. So the graph, okay, the picture is given there below that question. So you just sketch back again the graph, right? Locate the critical point. When you sketch, okay, for this thing here, when you sketch, you don't need anything, okay? You don't need, I mean, that is not to say you don't need anything. What you need is only the graph. Okay, you need the graph 0 lah, they exist, and then you locate the critical point. You don't have to put the scale. Okay, don't worry about scaling here because you want to sketch. Even you don't have to worry about the intercept. Don't worry anything. Okay, we are not going to get the intercept unless you want to find the intercept. So what you need is only the critical point. So estimate that critical point. Okay, critical point ini 4. And then negative 7. So somewhere there. So student. So that is the only thing that you need. All right, you don't worry about the intercept. So the function is decreasing on the interval to the left, decreasing, and then increasing. So, so that is y equal to f of x. And here you have what? You have a minimum. So conclude, yeah. All right. So therefore, the function here has a minimum at 4, negative 7. Okay. Or if you do the graph, then you argue from here. Okay. Argue from that. The function is decreasing and then the function is increasing. So therefore, the critical point is maximum. Okay. All right. Good. So I think we are done for this part today. We can do the graph. So here I have 67 students. So I think that is the number, the final number. You have a few students, dropping. So I hope, that will be the final number. So I give you the quiz. I give you some instruction dulu lah. All right. So you have half an hour, 30 minutes from now, okay, from where I show you the quiz until the end. So by 11:15, stop lah. All right. 11:15, you stop, and then you have 15 minutes to submit. Okay, submit to classroom. I will give you the work. Okay, I give you the work, and then you can submit over there. So you can submit to classroom. Now, if you have problem, scanning. Okay, scanning lambat, late, don't take time. So what you do, ambil gambar dulu. Okay, take picture of the pages. Okay, just take pictures by using your handphone. Take pictures and then send. Take picture cantik lah sikit. Okay, take picture clearly, send. So that send is the record lah for me. Okay, after that, you can send the scanning, the scan, the proper one. Okay, the scan one you can send later. But if the one that you take in the pictures already nice, tak payah hantar scan. Okay, so you enter the picture to the classroom. Nice. Put in one file lah, so that easy for me. Put one file. All right. Or if you still do not have the time due to things, you WhatsApp dulu. The picture ni you hantar WhatsApp dulu. Okay, hantar WhatsApp. So that I have a record. Okay, I have a record that you submitted, and then exactly the same thing you submit later lah to classroom. Okay, all right. So that is the submission. Any question? Clear? Okay, because I did the instruction, but some people still don't understand. Saya tak faham. Okay, so that's number one. Number two, you use pen. Okay, don't use pencil. Because when you use pencil, after you scan or you take picture, it will be not that clear. So pakai pen. Any mistake, cross dia. Bukan cross lah, buat lain. Jangan padam-padam. Okay, tutup, potong. Okay, any mistake that you want to do correction, potong. Okay, don't worry. As long as you write je cantik sikit lah. Janganlah hentam. Hentam je. Okay, you write nicely, normal lah, write normal. But if you do a mistake, don't have to erase, okay? Just cross ataupun draw the line. Okay, all right. Any question? Okay, so now I will show you the quiz. I will show you the question. There are only two questions, and you do it now. So first, okay, first I want you to read the oath of honor. Because this is online, you have to monitor yourself, all right? So we take the oath, so that we are accountable to what we do. So I want everybody to read this thing here. All right, read this thing, and then show all work. Okay, I already say write in ink, and then show all work. Whatever work, you don't have to have a rough paper. Okay, you don't need a rough paper. Write everything on the sheet that you want to submit to me. You don't need rough paper. Okay, show everything that you do rather than express. If you do express, then how do you get the answer? Okay, show everything. Rough work pun apa, hentam je atas kertas. Okay, so that I know what you are doing. Okay, so you can start now. I give you until 11:15. So good luck to you. Make a doa. Inshallah, you will get. Okay. All right. Okay. Okay. So write your name. Okay. Metric number. Section number. Because sometimes, in case you send classroom, it may happen that it is sent to another section. Okay. So, your name, metric number, section number. Betul. Full name tau, full name. Okay, so now you turn on your video. Okay, turn on your video so that I can see you doing the work. Okay, good, thank you. Cantik-cantik semua. Ada gambar apa benda belakang. Okay, kalau ada apa-apa, you can ask me. Okay. Nah, saya letakkan. Tak kacau. Ni apa saya? Dia tak ada video lagi ni. Budak-budak ni. Okey. Ni Aziz latih. Ni. Okay, turn on your video. Ni apa section 12 ni? This is not section 12. If you are in section 12, that means you don't belong to my class. Section 12 is another class. Okay, these people here, who Shafiq, Ilham, turn on your video, please. Okay, go ahead. Ni, No Farahin, Nasution. Okay, turn on your video. These people here. Okay, for those people who did not turn on the video, I will deduct your marks, I will deduct your marks. Okay, these people here, Ilya, Hu, Farahin. If you don't turn on your video, I will deduct marks, okay, because I have the record here. I will deduct marks for the quiz. I will take away marks.
Sorry, sir. If I turn on my camera, I will leave the meeting.
I will what?
I will leave the meeting. My internet is not good enough.
Oh ya ke? Kenapa pula?
Saya pun tak tahu.
Okay. So siapa nama ni? Siapa nama?
Ilham Hazmi, sir.
Macam tu sekejap lah. Okay. You tunjuk gambar kejap. Mana tadi? Ni Ilham Hakim ke? Itu Ilham
Hazmi, sir.
Dah masuk ke belum ni? Dah tunjuk lah skrin. Ilham. Ada kat sini. Ni Ilham ni. Okay, okay. So you tunjuk muka kejap. Lepas tu rejoin.
Sir, for question 2B, do we need to show the graph for ME? For question 2B, do we need to show the graph?
No, no, you don't have to. For the part B, no, no, you don't need to.
Okay, just show the points.
Yeah, yeah, you just find the equilibrium.
All right.
Okay, show the condition and then set equilibrium. Graph, you don't have to. Okay, you don't need. But if you want, you just sketch the graph. But it is not needed. It's not needed for the answer. Ini mana datang lagi 2 orang ni? You know, I have, before the quiz, I have 67 people. Now there are 2 more coming. So who are these people, 2 people ni? Who are these 2 people who just came in? Sekarang dah 58. Okay. Now these 2 people ni, bila pula masuk lah?
Sir, I have logged in 2 accounts. I'm seeing the question in my laptop and I have on the video in my phone. That's why.
Oh, so there are 2 of you lah.
Yeah.
Okay. So that's the reason. Okay, if you're finished, you can submit now. I give you 5 more minutes. Okay. I want you to stop now. Okay, whatever you have, you stop. Please submit. Okay, I give you 10 minutes for submission. Submit to the classroom. I already put quiz
I
one.
want to ask.
Yes, go ahead.
So there is a form in Google Classroom.
No,
So
no, you
first one
don't.
we need to.
No, you don't use the form. You just submit to the quiz one.
Okay, so just add file.
You just put your file into the quiz one.
Okay,
Okay.
thank you.
Tak payah guna form.
Okay.
I don't know how to use the form. So you just submit to the quiz one, which I already assigned. Okay, when you are submitted, you can go. Okay, you can go and leave the meeting.
Thank you, sir.
All right, thank you.
Thank you, sir.
Okay, thanks.
Thank you very
Thank you,
much.
sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thanks.
Thank you, sir.
Thank you, sir.
Okay, thank you.
sir.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Alright, thanks. Okay, stop writing. Cukup tu. Nanti saya tak cukup poin nak bagi pula.
Sir, do we need to rename the file?
No, I don't think so. You just submit, But
Okay, okay.
important your name.
Thank you, thank you.
Okay, you don't have to put a file. You don't have to put a name. You just need a name and then your number, section number. Okay. As long as it is in the quiz one.
Okay, done. Thank you, sister.
All right.
Sir,
Yes.
can I submit it in the picture, not screen, not scan?
Okay, you
Scan.
submit the picture and then you scan. Okay. You do the scanning later. All right.
Thank you,
Uh,
sir.
Okay, submit picture now so that I have a record that you submitted. Okay, and then afterwards, you scan and resubmit.
Okay, sir.
Okay,
Thank you, sir.
all right, thank you.
Thank you, sir.
Okay. Submit now.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Thank you, sir.
Okay, thank you.